Could everyone please turn on their cameras? All right, so as we went over recursion last class, today we'll be doing more practice on solving recursive problems using equations. Um, and if you remember, we went over some quick algebra last class about what a recursive function was. And also we did some practice problems on how to solve recursive functions. And so for today, we'll be starting with a quick Kahoot to go over some of the stuff you have learned before. Is everyone in the Kahoot at least?
Okay, so now I'll go over some of the trickier questions. Okay, so question 7 says, given f4 equals 40, f of n equals f of n minus 1 times 2, find f of 1. So basically using this recursive formula, we know f of 4 is equal to f of 3 times 2. And we know this is 40. So therefore, f of 3 is 20. And then same thing, f of 3 equals f of 2 times 2, which is 20. So f of 2 equals 10. And we are looking for f of 1. So f of 2 equals f of 1 times 2, which is equal to 10. So f of 1 is 5. So that's why 5 is the correct answer for this one. Okay, and then, so for question 6, we are looking for f of 3 given f of 1 equals 2 and f of n equals f of n minus 1 squared. So using this formula, we know f of 2 equals f of 2 minus 1, which is just 1, f of 1 squared plus 2. And f of 1 is the base case, which is given, which is 2. So this is 2 squared plus 2, which is 6. Okay. And f of 3 is f of 2 squared plus 2, which is 6 squared plus 2, which is 38. So 38 is the answer for this one. Okay, so this was an official problem. I won't go over it. The solutions are in the Google Drive. You can go take a look at it. Okay, question 5. We want to define it recursively. If you notice the pattern, each term is the product of the previous 2 terms. And we start with 1 and 2. So since each term is the product of the previous 2 terms, then that means 2 terms have to be the base case, which eliminates, I think, the second option, which a lot of you chose, because we have to have 2 base cases, f of 1 equals 1 and f of 2 equals 2. And then from there, f of n equals f of n minus 1 times f of n minus 2. So just be careful with the base case. Okay, and for the grid, this is not really a recursive problem, but basically, I don't know how to enlarge the picture, but basically you can count how many ways there are to travel to each square, and then the next square would be the sum of the 2 squares that are adjacent to it, the square that is up and the square that is left of it. And the Hanoi Tower problem is a fun one. So we have, basically we're trying to transport the tower from the leftmost spot to the rightmost one. So, okay, let's say we have 3. This is the same thing as moving the first 2 over here. And this is the same thing as f of n minus 1. And then next we move the bottom one over here. So we're adding 1 because that is 1 extra move. And then last we move these 2 on top. So that is another fn minus 1. So basically we have this formula. And then we know f1 equals 1. So from there you can calculate f of 5. And you'll also notice f of n is equal to 2 to the n minus 1. This is the iterative formula, but this one I have up here is the recursive formula. And that's it for the explanation. I'll hand it back over to Aiden.
Thank you, Richard, for those explanations, and hopefully those cleared up some questions you all may have had. So going back to our class for today, we're gonna start off with some review questions for the stuff we learned last time. If anyone needs or has any questions, you can ask in the chat. Seems like a lot of people are getting answers, so I'll give everyone a few more seconds and then I'll explain it. So if we look at the question, we can see that we have three different cases that are possible. If x is greater than 10, greater than or equal to 10, then f of x is equal to f of x minus 3 plus 1. Then if x is between 5 and 10, it's equal to f of x minus 2 and then minus 3. And then our base case here is that if x is less than or equal to 5, then f of x is equal to x squared. And so starting off, we start with f of 18, which is what we were trying to find. And so if we look at the three cases up here, 18 is greater than 10. So f of 18 is equal to f of 18 minus 3, which is 15. And plus 1, since we're following this case at the top. And so now we're trying to figure out what f of 15 is, so we can solve what f of 18 is. And so f of 15 And 15 is still greater than 10, so we're still following the case here at the top, which gives us f of 12 plus 1. And so we repeat the same thing, but this time for f of 12. And we're still going with the top base case. So we get f of 9 and then plus 1. And finally, since 9 is smaller than 10, we follow the second base case. There's a second case here, sorry. And that gives us f of 9, which is equal to f of 7 minus 3. And then f of 7, since we still haven't reached the base case here, f of 7 would be equal to f of 5 minus 3. And finally, we have f of 5, which meets this requirement. So then f of 5 is equal to 25. And now that we have f of 5, we can figure out what f of 7 is. So since f of 5 is 25, then 25 minus 3 would be 22. And then since f of 7 is 22, and then f of 9 is f of 7 minus 3, and 22 minus 3 is 19. And then we can repeat the same steps since f of 9 is 19, and f of 12 is f of 9 plus 1, then f of 12 has to be 20. And we can keep going up. So it's 21. And then finally we reach f of 18. And our final answer is that f of 18 is equal to 22. Does everyone understand how I got there? All right, we can go to the next question. It seems like a lot of people are getting answers, so for the sake of time, I'll explain this question. So here we are trying to find f of 12 comma 21. And so this in this case, 12 is our x and 21 is our y. And since x is less than y here, we follow the second case. And to be careful, you have to remember that the y and the x switch places here. So this would give us f of y minus 1, which is 20, comma 14, since it's x plus 2, and then plus 1. Now, since the x is 20, we follow, and 20 is larger than 14, we can follow the first case. So f of 14 is equal to f of 19, comma 16. Since you're subtracting 1 from here and subtracting, and adding 2 to here. And then finally, you have to subtract 3. And so to figure out what f of 20 comma 14 is, we need to figure out what f of 19 comma 16 is. And since x is still greater than y, we follow the top case again. Now, if you pay attention, you get to f of 18 comma 18. And here, x is equal to y, since 18 is equal to 18. So that means that f of 18 comma 18 leaves us with 18 as our answer. And plugging this back into the top, we can see that this gives us f, since f of 18, 18 is 18, then 18 minus 3 is 15, which is the answer for f of 19 comma 16. And subtracting by 3 again, we get 12. And then adding by 1, we get 13 as our final answer. And sorry if I confuse people by saying that 18 was the answer, but 13 is the final answer for this one. And does everyone understand how I got there? Why do I subtract 3 after 18 comma 18? So since if you look at the cases up here, we're still following when it's f of 19 comma 16, we're following the top case here. So when I expand it and write it out as this, you see the 3 at the end right there. That's why we have to subtract 3. Since it's just that when we're like writing out the function, it has a 3 there. Okay, we can move on to the next question now. seems like a lot of people are getting mixed answers, so I can explain. Sorry. So if we look at the question, and we look at the three cases, if x is even, we follow the top case. If x is odd and greater than 3, we follow the middle case. And then if x doesn't meet either one of these, then we follow the last case. So if we look at the question, we have to find what f of 20 is. And since 20 is even, we follow the top case, which is f of x divided by 2. And 20 divided by 2 is 10 plus 1. And so we have to figure out what f of 10 is now, since we have to figure out what this is to figure out what f of 20 is. And since since 10 is still even, we still follow the top case. So 10 divided by 2 is 5. Now since x is finally odd, we follow the middle case since x is odd and is greater than 3. So f of 5 gives us f of 8 minus 1. And since since 8 is even again, then we have to go back to following the top case. So 8 divided by 2 is 4. And since f is still even, we follow the top case once again. It gives us f of 2 plus 1. And now since since 2 is still even, we still follow the top case once more. Which brings us to our base case finally, since 1 is odd and less than 3. So f of 1 is equal to 1 since x is 1, and so 1 plus 1 is 2 divided by 2 is 1. So now that we know what f of 1 is, we can work our way back up the ladder. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 minus 1 is 3. 3 plus 1 is 4. And 4 plus 1 is 5, which leaves us as 5 as our final answer right here. So those of you who said 5, you are correct. Okay. We can move to the next question now. just really quick, remember that you were looking for f of 17, so like remember to solve for the full problem. Okay, so it seems like a lot of people are getting answers, so I think it's about time to go over this one. So remember that in this question, we're looking for f of 17, so you can kind of break this question down to two steps. So first, we can kind of try to figure out what f of 17 is. And so f of 17. Since if we look at our cases, if x is greater than or equal to 8, we follow the top case. So that means that f of 17 is equal to 2 plus f of 17 minus 2, which is 15. Then we can continue solving for f of 15. And we can keep going with f of 13 equal to 2 plus f of 11. F of 11 is equal to 2 plus f of 9. Finally, we get f of 9, which is equal to 2 plus f of 7. Now that since 7 is less than 8, we can follow the bottom case here, which is our base case, which brings us to f of 7 equal to 3. And working our way back up, and remember that we're solving for only f of 17, not f of 17 here. If f of 7 is equal to 3, then f of 7 plus 2 would be equal to 5. That means that 5 plus 2 is equal to 7. And then f of 11, which is equal to 7 plus 2 is 9. And adding 2 again, we get 11. And then 13 would be the answer to f of 17. But the thing is here that we're solving for f of 17. So once we have this, we can kind of break this down into second step, which is since we're looking for f of 17 and f of 17 is equal to 13, then basically we can replace this here with 13. So essentially now we're looking for f of 13. And so if you look at the steps we did earlier, you can see that f of 13 we already have an answer for, which is 9. And so that would be our final answer. And you can kind of remember this as f of 17. I know a lot of people got confused on this last step here, since it kind of looked like you were trying to solve for f of 17. That's okay. I'm afraid that we are out of time, unfortunately. There's a few more questions left. Maybe you guys could try this one for homework. This one's actually pretty tricky. I think it's a good question. If you're doing this, just remember to look for patterns. That'll like shorten the process by quite a bit. But I think our class for today is over. Thank you, everyone.